All right, so here we go. We're starting up. You need your math notebooks. This is a greater than, less than, or equal to deal, y'all. So as soon as we have math notebooks out, and people on the Zoom, did you get that attachment that I sent?
Yeah.
Okay, it doesn't matter if you can print it out. You can just do the problems on a piece of paper and draw the circles. I never grade those because I have you work on them on your own, and then we go over them tomorrow to make sure that everybody kind of figured it out the same way, okay?
Okay.
So if you did print it out, that's awesome. If you can't, don't worry about it too much, all right? And you guys will all understand later. All right, so we've got these. I don't want to read them because then I think it'll give it away for some of you. We're comparing, it's either a greater than or less than. Now, again, I'll teach you that when we get there. So write in your greater than, less than, or equal to signs. So, yeah, I feel like these should go fairly quickly. First one, what sign should we have, Porter? And here's how you know. Porter, if you're not sure, you just read the sentence. And which one's bigger, left or right? Okay, the right one's bigger. So then you would say that 5,000, you read the number. Is what? 5,609 is? Greater. Are you sure this one's greater? Yeah, you just read the sentence and you'd say whatever it should say. 5,609, you said is? Less than. So that's your less than sign. Another way that, and it used to confuse me a little bit because I don't know why, I just had a mental block. It also kind of looks like an L if you were to take this part right here and drop it. You guys see that? Or if you took that L, let's see if the smart board is being smart today. Probably won't let me rotate that, but if you could rotate it, you guys see how it could look like a less than sign? Oh, that's smart. Yeah. See, I'm full of useful tricks. Okay, next one. Braylon, how about this one? Greater than or less than? Read the sentence. You're muted.
840 is greater than, 8,040 is greater than 8,004.
Oh, couldn't have done that any better. The only thing I would have said is it's not 8,004, it's 8,004. That's just a nitpicky thing. We knew what you meant, but it's a thing that we need to get better at. Hey guys, I'm going to power through. Okay. In the interest of maybe getting to science today. I know we probably have some real interesting things to share, but maybe we can share them later, okay? Thank you for your understanding. All right, let's get these guys done. And that's how, if I call your stick, that's how I want you to do it. Read the number, say what it should say, read the number, okay? Those two, Porter and Braylon, did an awesome job. Lisbeth, which is a quicker way of saying Elizabeth. Although, is it quicker when I have to explain it?
No.
I'm gonna keep doing it. All right, go ahead.
12,453 is greater than 11,453.
And now we're going to add an extra layer to this. How did you know?
Because two is bigger. One is smaller than two, and because the first ones are the same, so you would look at the second ones, and two is bigger than one.
Okay, very good. If I were to add something to that, or like, because I'm modeling, and Elizabeth, you did a fantastic job. You said the first numbers are the same. I would maybe say that 12,000 is more than 11,000. Do you guys see how I did that? Yeah, basically I just rounded it, didn't I?
Mm-hmm.
So now you have to read it and tell me why, because I'm super mean. Braxton.
90,600 and 90,667
Excellent.
is less than 90,677
Yep, very good. And how do you know?
because the first three numbers are the same, and then if you look at the fourth number, the first one is a 6 and then the second one is a 7.
Okay.
The second
You
one.
can even go so far as to say you did an awesome job. Again, I'm just adding to it, or I'm modeling my thinking, how I would have done it. Braxton, your way was fantastic. I'd have just said, this is 10 more than that. This has a 7 in the tens place. This has a 6 in the tens place. The challenge that I'd like you guys to start using on this is to talk about the places. Use your place values. I noticed that all the numbers are, like for this one, I noticed all the numbers are the same. Hey, you can't be learning or understanding what I'm modeling if you're not in it. So I need eyes. Hey, how is drawing the corner of your paper helping me? I whistled, I talked, I tried to get you redirected and you didn't do it. So now I need you. On this one, you could say all of the numbers are the same except the thousands place. That's another way you could do it. I really want you guys to start thinking about your place values, because the more you talk about place values, the better you're going to understand place value. And some of you are probably like, oh, I totally get it. Well, okay, that's awesome. But it doesn't hurt you to use that terminology. It's actually probably, instead of going, there's a 2 and a 1, go, there's a 2 in the thousands place in this one, and a 1 in the, you guys get what I'm saying? It's better mathematical language. So I'm challenging you guys, because you guys have shown how great you are at math, to do even better. If I just said we're good, then am I really doing my job?
No.
The point is, every day we need to get a little bit
Better.
good. You guys do listen to me once in a while.
And remind yourself, you said once in a while.
That's true. Not all the time, for sure. Eva. Okay, you're forgetting one thing at this comma. What should you say? Very good. 587,000. And did you say is greater than or less than? Very good. How did you know? Can you be just a tish louder? I'm old and hard of hearing. It's the 10,000s. You were right. And you have an 8 in your 10,000s here. And everything else in there was it's just like they flipped this, right? Yeah, very good. Very good. And I guess that's not true either, because their thousands place is different, but that's where you'd be looking. Very good. You did a great job, Ava. I don't think we have Maddie with us today. So, Gavin, this last one. Chase, those little extra noises, I know you're having fun and entertaining yourself, but it makes it harder for me to hear, because my ears work really weird. I can hear like auxiliary sounds, like I can hear a pheasant coop or cluck 3 miles that way with a roaring wind. But when someone's talking, it's hard for me to pick it up. And I think it's all my years of like landscaping and working on my grandparents' farm. All that noise probably damaged my ears to some degree, and I'm going to need hearing aids. So the little noises like that, I pick those up really well, and then I can't hear the other students. That's why I need you to not do that. Go ahead, Gavin. Okay, and where did you have to look? The 1,000s place? 100,000s place. Very good. Because your 7 million is the same. You had a 9 in your 100,000s. You had an 8 in your 100,000s. So 7,900,000 is more than 7,800,000. Because does anything behind that matter?
No.
No, nothing behind that matters at that point. It's kind of like rounding, right? All right, very good. All right, now in your math workbooks, you need to get to page 81. Yeah. And kids see this and they get really worked up about it because you gotta, this one is gonna make you think just a little bit about the size of fractions.
This one's not that big.
No, it's really not. It's actually really super easy. So here's what we're gonna do. It says each of the rectangles below is one whole unit. Label each strip with the following fractions: 1/10, 9/10, 7/8, 4/7, 2/5, 1/8. You're going to want your math journal because we're gonna draw these with circles as well, so we can compare them. Okay? Everybody understanding what I'm saying? It says use the benchmarks of 0, 1/2, and 1 to help you. So here's what I want you to do right now with your pencil. Down here by this end, this is 0. It doesn't have to be perfectly in the middle, but pretty close to 1/2. You should put 1/2. And way down at this end, this is 1. Because that's really important information. You want to make sure your half is around the half mark, because if it's not close, then it's going to lead to some problems of whether something is a half or not.
Mr. Roth,
Yep.
I'm looking between my 84 and my 85, and no, not 84 and 85. Oh wait, never mind.
Yeah, this is 81, kiddo, okay?
Oh, okay.
I'm sure I've torn some things out of your book when I've graded them, and that's why you're missing pages, because then I put those in your stapled papers. Okay, so here's what we need to do. Why that's important, why that's helpful to know if it's closer to 0, closer to 1/2, or closer to 1, is because when you look at fractions, you should be able to determine where it should lie. If you look at 1/10, is that more than a half or less than a half? If I have a piece of pizza and I only have one piece out of it, is that more than half or less than half?
Yes.
So could this one possibly be 1/10?
No.
No, logically it can't be. Okay, your eyes need to, we're not working on this on our own. We need to be here. We're working through this together. This is today is a together day. So don't be going rogue on me. I know some of you are super duper good at math. Okay, so sometimes what I do when I'm doing something like this is when I know that this is less than a half, I put an L by it. Because now I know that it's less than 1/2. I know that whatever one this is has to be on this side of a half, right? So let's go through these and think about them. If you ate 9 out of 10 pieces of pizza, did you eat more than half or less than half?
More than half.
You ate more than half, so I'm going to put an M by this one. You might want to do the same. It looks like an M because it got kind of smushed. I'm going to fix that. That's a more. How do we know? How do you know that's more than half? Explain to me how you know that's more than half. Chase.
Because the green line stops right after the half.
Okay. Anybody have a different way to know? Mackenzie.
I do.
If you think about it, one next one kind of is 9, so then you have one more piece left, and if it was 1/2, it would have a bigger piece that's a 1 piece left.
Okay, it's only one piece away from the tenths. It's only one piece away from being 10 tenths. How about this? What would half be? 3, 2, 1. What would it be?
5
5 tenths. That's how I know. Okay, how about the 7/8? More than half or less than half?
more.
Okay, this is another more. Now, 4/7 sometimes confuses kids because, well, what's half of 7? And some of you can probably do that. But is 4/7 more or less than half?
More. More.
Okay, let's think about this. All right. I'm going to help you think about this, Braden. I don't know what you're doing underneath the table, but I need you here. If 4 is our numerator and it was equal to half, what would your denominator be?
8.
4 is half of 8. So if you have 4 out of 7 pieces, is it going to be more than half or less than half?
More.
It's going to be more because you have 4. Think about there's 7 pieces. If I eat 4 of them, I'm eating 4. How many pieces are left?
3.
So is it if I'm getting 4 and somebody else is getting 3, who's getting more? Me, yeah. So the 4/7 is also a more. Now we kind of got to do 2/5 the same way. Okay? I have 2/5. That means the other side would be 3. More or less than half?
Less.
Less. How about that 1/8?
Less.
Way less than a half, right? So again, this is taking a lot of time because I'm modeling some things that can help your thinking. Now, here's some other things I do. And Mackenzie kind of hit on this. Is 1/10 close to a half or a long way away from a half? Long way away because it's only one piece. How many pieces if I had 1/10 do I need to get to a half? I need 5 total, so I need how many more? 4. How about 9/10? Closer to a whole or closer to a half? 7/8, closer to a whole or closer to a half? 4/7, closer to a half or closer to a whole? Closer to a half, yeah. You guys see how I'm getting these ideas in my mind. So if I look at this one right here, which 2 could this possibly be for number 1? If you look, we're really close to being filled into 1. So which 2 could it possibly be? Talk with a partner. And now that we have people back, we'll go back to our original group of 3, whoever that was. Ready? Talk to a partner.
I'd probably think this one would be if you said no, sometimes the top one is
1, 2, 3, eyes on me.
1, 2, eyes on you.
Very good. Braden, what's one of them that it could be? Okay, I just asked for one. You gave me both. I guess that's okay. So we're looking at 9/10 and 7/8. And if you look on this page, is this one the most filled in or the second most? We have 2 that are really close, right? Which one's bigger? Number 1 or number 4? Number 1. So number 1, we're looking for the biggest fraction. So I'm going to show you how to draw this, and maybe it'll be easier to compare because you'll have them right next to each other. You could do this in your math notebook or on a piece of scratch paper. Start by making a circle. Make them about the same size. I know mine aren't. I'll try again. Here is how you make tenths. You guys ready? Make a dot in the middle, draw a line down. Then, make two going like that. Now I know they're not perfect. This is the best way you can make it. Right now you have fifths. You gotta split each of them. Cut them in half, each one. Because 5 times 2 is 10. Color in how many of those? 9. For eighths, I'm maybe going a little fast, so I'll wait a sec. I would do this in my math notebook or on a piece of scratch paper. You make fifths, and then you split each one in half. Here's how you make eighths. Split it in half. Then split it in half the other way. Now I have fourths. See that? Now I split each fourth in half with 2 more lines. How many of those should you color in? Now watch. This is important. This is important because I think it'll help you. If I left this one clear, I'm going to probably leave this one. So they're kind of in the same area. Does that make sense? So I'm going to go like this. Get that far and then we'll talk. We'll discuss. We'll discuss. Discuss? Discus, like in track?
No, disgust.
Well, but look, here's discuss.
Did you just say disgust?
No, discuss, like talk about it. But isn't that also discuss? It might be spelled differently. Okay, here we go. So here's what you got to think about. How many pieces is this away from being a whole?
1.
1. It's missing 1. 1/10. This is missing 1/8. Always the denominator, right? Denominator is going to be the same. So here's what you got to think about. Pretend for a second that we have a pizza, okay? If I cut it into 10 pieces, let me rephrase it. We got 2 pizzas. And everybody's going to get a slice. So, and this actually works out because we have 18 students in our class, so it works out great. I cut this pizza into 10 pieces. I cut this pizza into 8 pieces. The pizzas are the exact same size.
Okay.
Which piece is bigger, the tenths or the eighths? The eighths are bigger because the more pieces that I cut, the smaller the pieces get. The less pieces you have, the bigger the pieces are. So this is missing 1 piece. This is missing 1 piece. Which one is missing a smaller piece?
10.
The tenths are missing a smaller piece. So this is actually, 9/10 is actually more of the pizza, yes? This is a weird way to think about it. And it can confuse kids a little bit because now you're thinking about which one is missing a smaller piece. Now, why I gave you that first scenario is because I wanted you to picture the pieces being cut smaller and smaller, right? Now I'm going to give it to you in a different way to make you conceptualize it in a different way. You walk into a pizza shop. They sell pizza by the slice. So when you order a piece of pizza, you can take just 1 slice, right? But they leave the pizza together. and they'll like take their spatula and scoop it out and put it there. Or you could buy the whole pizza and they'll put it in a box for you. You walk in and there's two pizzas. One is missing 1/10, one is missing 1/8, and you need to buy as much pizza as you can. Which one has more pizza? 9/10 or 7/8?
9/10.
Because the piece that was taken out was smaller. You guys understand what I'm telling you?
Mm-hmm.
So which fraction is bigger, 9/10 or 7/8?
7/8.
9/10.
Okay. Yep, okay. Mackenzie, you took out one smaller piece, right? Versus one bigger piece. So 9/10 still has more pizza there. Does that make sense? Okay. If I take this piece out and this piece out, which one is missing a bigger piece? Which one's that? 1/8 is a bigger piece. So if this piece is missing, there's less pizza here than there is here, yes? Now does it make sense? Good. Okay. So what is this one then?
9/8.
We decided this one is 9/10. But also now we have some really important information. We should also be able to do another one. Which other one should we be able to do?
4.
Number 4. Write in what number 4 is.
Number 4.
Delia, what should number 4 be then? It's the second largest fraction that we have. You might be muted.
Then it would be 9/10.
Yep, number 1 is 9/10. How about number 4? You've used 9/10. You said the biggest fraction bar was 9/10. What's the second largest one, number 4?
Oh, the second largest?
Yeah,
Oh.
we're doing this one, Delia, number 4. Which one, which fraction would go?
Oh, okay. 7/8.
Excellent. Great job, Delia. All right. So now the next two that I want to look at, even though it's out of order, is I want to look at 5 and 6. Because those are our two smallest. Right? So we're looking at the ones that are L, less than half. Which two fractions are going to be the smallest? Figure that out right now. So I'm going to draw some sticks. Which two are probably 5 and 6? Don't write them in yet. We're going to draw them out like we did before. Which two are possibilities for 5 and 6, Roger? Okay, I didn't want to know which one was which because I wanted to draw them out. I just asked you which fractions we needed, and hopefully, like normal, some people maybe weren't listening. So the two fractions that we're looking at are probably 1/10 and 1/8. It's kind of like the reverse of what we just did, yes?
Yes.
Okay, so what we need to do is we need to figure out which one is the smallest. So let's draw our circles. They should be about the same size. Hopefully that's still in the picture.
Yep.
Excellent. To make tenths, I start by making fifths, which is kind of like a star. And then I just split each of the sections. And I know they're not perfect, and I'm only going to color in one. Now, when I'm trying to figure out if something's the smallest, and it's probably a little bit of cheating, but I always pick like the smallest one to color in. So I'm going to color in the smallest one. Over here, I'm going to make ace. Well, again, I'm going to pick the smallest one. Kind of in the same area at least. Again, I would be drawing these in my math notebook so that I can look at them. And I can observe them. I would be drawing them. If I do it, you should be doing it. Because I could probably do this in my head too, but I'm doing it. And if I think, if I'm drawing it, maybe it's a good thing for you to draw it. Okay, so when we talked last time about 1 and 4, Elizabeth, I don't know why we have a ruler because right now we're doing fractions. Can I do what? Okay, yep, hurry up. Let's listen to the announcement.
Good morning. If I can have any paras that are available, I just need about 3 minutes to meet in the gym. Any paras that are available to meet in the gym, just very briefly. Thank you.
So here's where we're going to try to establish a rule. I need us here because this is going to be a rule that'll help you. When we talked about this earlier, we discovered that the bigger the denominator, the smaller the pieces. What is the rule? The bigger the denominator, the smaller the pieces. So as you cut this into more and more pieces or divide it into more and more pieces, the pieces have to get smaller. Yes?
Yes.
Yes. So the smaller the denominator, the flip of this is the smaller the denominator, the bigger the pieces. So a seventh would be bigger than an eighth, but a ninth would be smaller than an eighth. Make sense?
Yeah.
Everybody following the rule, because that is a key rule. You need to kind of have that idea. And I know that this is the first day that we're kind of learning this, so I don't expect you to have it mastered, but does everybody understand what I'm saying?
Yes.
Yes.
Okay, make sure you're not drawing or coloring or doing something else. I need to hear it. So here's the scenario this time. You walk into that same pizzeria that they sell pizza by the slice, and you are hungry. All right, okay, yeah, we're gonna go this way. You're hungry. You want to get the biggest slice you can, but you only are going to buy one slice. Would you buy the 1/10 or the 1/8? You want to get the most pizza you can buy. You're not writing anything down, you're just thinking about it. Which one would you buy if you were hungriest? You want the biggest piece, 1/10 or 1/8? Class.
1/8.
Yes, you buy the 1/8 because it's bigger. So therefore, 5 is the smallest fraction. Which one of these is smaller, 1/10 or 1/8?
1/10.
So 5 should be what?
1/10.
And then we should also be able to do 6, correct?
Yes.
Okay, get those written in now. Mackenzie, what should number 5 be?
Number 5 should be 1/10.
Excellent job, Mackenzie. Parker, what should 6 be?
It should be 1/8.
Awesome job. Okay, we good? We ready to move on?
Yes.
Okay, what I want to see right now is when comparing fractions. Fist to 5, where are we at? 5 again is I can teach this to someone else. 4 is I can do it on my own. 3 is I can do it, but I might need some help. 2 is I'm not quite sure and I probably need a lot of help. 1 is I'm really confused, and a fist to 0 is I don't even know what class we're doing right now. Where are we at? On your, I want to see fingers spread. This doesn't, I don't know, that's like a paddle. Give me fingers spread. On your chest is where I want them, because then I can see them. Right now I'm doing fist to 5. If you have something to say, right now I want it on the chest, Chase. There you go. Very good. Okay. It's our first day, so maybe it'll get better. I'm seeing lots of 3s and 4s. All right, very good. All right. It'll get there. It's going to get better. Let's take a look at this now. The last 2 that we have are 2 and 3. And if we look up here, we've used 1/10, we've used 1/8, we've used 7/8. So we have 4 7ths and 2 5ths. And guys, this one's super easy because we did this step. One of them is more than half, one of them is less than half. One of these bars is more than half, one is less than half. Write in what they should be. You should be able to do it without even really needing to compare them. It would have been nice if you would have done this, not notebook so that I wouldn't have to redraw it. That's why I say it. I do it, you do it. That would make my life a little bit easier, okay? So I'm coloring 9. Then coloring 7. Right. The bigger the denominator, the smaller pieces. So if this is a piece and I put it into 10 pieces, this one piece is less than 1/10 is less than the 1/8.
I don't know how to make it.
So this is missing a smaller piece. So I mean, this, the chlorine part is bigger than this. Now where are we at this part? Let's jump this up quite a bit, so I'm good with that. Danielle, what's number 2? 4 7ths or 2 5ths?
4 7.
How did you know?
Yeah, 4 7 is bigger than 2 5.
Awesome. It's also more than half, right? Very good. Autumn, well, explain why this one has to be 2 5ths. We know it's 2 5ths. Explain how you know.
2 5ths is less than half.
2 5ths is less than half. This bar is to that side of the half. So it's less than half. All right. I think we did a good job. Again, the thing to remember here, what's the rule? Well, there's 2 rules, but it's essentially the same. We're just saying it in different ways. 2 rules to remember. The bigger the denominator, the smaller the pieces. I mean, think about it. Here's another example. You get a cake for your birthday, and you cut it into 10 pieces. Imagine that. But then 10 more people show up to your birthday, and you have to cut them in half. Did the pieces get bigger or smaller?
Smaller.
When you were going to get 1/10 of a cake, you got a bigger piece. When there were 20 people and you only get 1/20th, your piece is half as big, right? Makes sense? Yep. So now,
Yes.
that's one rule. The bigger the denominator, the smaller the pieces. The smaller the denominator, the bigger the pieces. Okay, so there's 2 pizzas. One's cut into 12ths, the other's cut into 6ths. You're hungry. Which one do you want a piece off of?
The 6.
The 6th, because it's going to be a bigger slice of pizza. Yep. There we go. You guys did a great job with this. So now we're moving on. This is going to be mostly on your own. This is all about pizzas, which is why I was talking about pizzas. So put your name on the top of page 115. Jackson, what's up?
Now you're making me hungry.
Good, because you're only about an hour away from recess and lunchtime. So
What about in the gym?
what thing in the gym?
Not prepared.
Are you a paraprofessional? Paraprofessional? Those are the people that help. Well, I generally just call them like adults or teachers. They're the people that help us in the help teachers in the classroom and then watch you guys on the playground. Hey, move that forward, you don't sit like that. So you don't want to break this hip. I don't know where the heck that came from. Why that's in mine.
Ow.
Everybody should have this one with veggie pizzas on it.
Veggie. Yep.
Nope, I don't.
I sent it to you in the email.
Okay.
And if not, I'll have it up on the board.
Which side?
Well, right now we're on 115.
Yeah.
Because 115 comes before 116. Okay, so in this, I've shown you how to make fifths, yes?
Yeah.
Very good. Then we should be in good shape. Has everybody got their name, number, and date on it?
No. Yes.
Then let's do it now so that I don't have to wait any longer.
No.
You are going to work on this on your own. I'm going to give very little help on this because tomorrow I'm going to go through it with you. So you have to just do your best. And if you get it wrong, it's not going to affect your grade because we're working through it together tomorrow. But the idea here is for you to try and use all the things that I've taught you about fractions, the rule that I taught you today, the bigger the denominator, the smaller the pieces, the smaller the denominator, the bigger the pieces, to compare how much pizza kids are getting. Is everybody ready? Name, number, and date is on. If I walk around and was going to give a dojo point for everyone that has their name on it, everyone would have it on?
Yeah.
I hope so. Veggie pizzas. In a fourth grade class, small groups of students went on different field trips. The cafeteria prepared 17 veggie pizzas for the students. Since each group had a different number of students, they were given different numbers of pizzas, as shown in the diagram below. All of the pizzas were the same. So if you look at this, in the first box here, 4 students went to the forest preserve. Everybody understanding what I'm saying here? So every student needs to get the same amount of pizza. We're not worried about chaperones. For whatever reason, let's pretend that they had their own lunch or their pizzas just don't matter here, okay? Everyone understand? These are just the pizzas that those 4 students get. How many pieces would you have to split each of those pizzas up into? 4, because we want to make sure that each person gets the same number of pizzas. And when we've done this before, what I do to make sure everybody gets the same is I split it and then I number it. So I know like student 1 got this piece, student 1 got this piece. You guys understand? Okay, so you might want to split this into 4 pieces. Over here, 5 students went to the farmer's cornfield. What do you think you should split those pizzas up into?
Fifths.
And does everybody remember how to make fifths?
Yep.
Okay, I'm going to show one more time how to make fifths. Everybody needs to pay attention because this is going to be something that you need to be able to do on this worksheet. So if you don't know how to do fifths, this is your reminder to look at me to learn how to do fifths. Here we go. In your circle, it kind of looks like a star. And it doesn't matter if they're perfect. 1, 2, 3, 4, 5 pieces. See that? All right, very good. Down here, 8 students went to the wild meadow. The easiest way to probably do that is to make sure that each pizza is cut into how many pieces?
8.
That's probably the easiest way. And here, 5 students went to Riverside. We already talked about the 5, right? Okay, so what I would do is I would start by figuring out what fraction of a pizza each student got at each field trip by doing just what we talked about. Everybody good on that? Because on the back side of this, there are 2 questions. The first one says, in which group did the students have the greatest amount of veggie pizza? That's what we just did on page 81, right? We compared fractions. What's more, Now, what you're going to want to think about is it more or less or equal to half? Remember when we did that as our first step? And then, because if there's a few that are less than half, did they get the most pizza? No, you can eliminate those right away. They're smaller than the ones that got more than half. Yes? Good. Use diagrams and words to show your reasoning. Now, if it says diagrams and words, does that mean words are optional? No, you need to say the students at Wild Field Corn Maze, whatever, I don't remember all the names of the things they went to, got the most because, and explain. You need to have words, and it needs to be a sentence. Sentences have a subject and a predicate. They start with a capital letter, they end with a punctuation mark. You guys are good writers. I've seen you write. You guys can write sentences. The diagrams, that's what we did. That's like saying, okay, I found out that they got 3/4 of a pizza. Each kid got this much. And at this other place, they only got a half. So at place 1, they're getting more than half. This is not the correct answer. I'm demonstrating, right? The students at this field trip got more because this is equal to half and this is more than half. Understand what you're doing? Now, I can help you a little bit, but I don't want to do this for you. If I do it for you, I'm not seeing what you know. And again, even if it's a little confusing, we're going to go over it tomorrow. So do your best. When you're done, hand it into the math bin so you don't lose it. People at home, figure out what you're going to do to not lose it, okay?
Mm-hmm.
All right, I'm going to stop the recording.
Mr. Roth.